So we have known the diseases associated with high cholesterol level, and simvastatin is used to decrease the cholesterol concentration in blood. So to fully understand the mechanism of how simvastatin works, we have to look at the mevalonate pathway of cholesterol synthesis, particularly focus on the rate-limiting step. Firstly, when simvastatin enters the body, it is synthesized via the cytochrome P450 enzyme and is hydrolyzed the ester bond into a free carboxylic acid and a free hydroxy bond. And in this active form, simvastatin binds to the active site of AMG-CoA reductase and inhibit the reduction of AMG-CoA into mevalonate. Let's look at this in more detail. So at the active site of AMG-CoA reductase enzyme, the AMG-CoA come in bind to the active site, and there are two molecules, NADPH, come in as well, and the double hydride transfer occur. The double hydride transfer attacks to the carbonate group and inducing the leaving of S-CoA group and ultimately forming the mevalonate. So how can simvastatin actually compete with the binding of AMG-CoA? So let's look at the simvastatin pharmacophore. It is structurally similar to AMG-CoA, so it can compete for the binding. So, but simvastatin in this case is bind more strongly to the active site of AMG-CoA reductase because of the extra hydrophobic interaction contributed by the butyrate and the decline ring. And the second reason that simvastatin is more stable than AMG-CoA is that you remember the S-CoA group being kicked out of the AMG-CoA? Well, in simvastatin, the S-CoA group is replaced by the hydrophobic Bucci group here, and the bond attached to this carbon here is very stable and is not easily broken upon the hydride transfer. Okay. So that makes simvastatin more stable than AMG-CoA at the active site. Let's look at the binding in more detail. So this is the AMG-CoA light group. So like AMG-CoA got the ionic interaction with lysine 75. The beta hydroxy group had hydrogen bonding with ASV 690 and serine 684. The hydroxy group at the 4th position had hydrogen bonding with lysine 691 and glutamine 559. However, the most important part is the hydrophobic interaction. When starting binding to the active site of AMG-CoA reductase, the alpha helices actually form a shallow hydrophobic interaction with this hydrophobic group, and therefore it's form a stronger interaction with the active site and compete for the binding with AMG-CoA. So AMG-CoA is less likely to be reduced in the active site.